All right. Hi, good afternoon, everybody. So today we're going to be starting a new topic. So once you guys can hear and see the screen, let me know.
Yeah.
Okay, so one person confirming. Everybody just shoot me a quick message in the chat so make sure we're all here ready to start. So far I see Myrtle and Cloris. So just checking in with Alicia and Janella. Are you guys here? Are you with me?
Yeah.
Okay, no problem. All right, no problem at all. All right, so today we're starting a completely new topic. Just a heads up, we're gonna try cover 2 topics before the end of the year because I do not want us to go into January without at least covering half of the content so that we can begin our past paper practices. And to reach to that stage, we definitely have to cover the content in itself. So there might be either an additional recording per week, or there might be another live session per week on Sunday. So for those who can't make it, you look at the video in your own time. Those who can, we work through certain questions and all that good stuff. All right. So, general question. I would have sent you guys this specific handout. Did anybody get a chance to read through it, even if it's just a peek? Did you get a chance to look at it at all? Read through it, taking any information, notice anything? So one person is saying yes. Anybody else? If you didn't, that's okay. At least I just need to know if anybody have any pre-knowledge of what we're about to do. Okay. If you didn't get a chance, that's perfectly fine. That's no worry. Even if it's like one page, that's fine. That's perfectly fine. Okay. So we're gonna go from scratch. So first thing first, what I would recommend though is that you guys print this document because it would save us so much time for you to have the information printed. And 2, you can add everything we do in class to the document. So the document is like a summary. And so all of the examples, all of the things that we're going to go through would be essentially based on what we going to do in this topic. So just to quickly zoom in, our topic for today is function relations and graphs, but we're not going to do the graphs now. We're going to do the graph portion at another time. So for now, let's look into what we see as a relation. How I like to teach relations is making use of, let's say, a machine. So we have a machine, and the machine basically gives us some instructions. So the machine gives us some instructions. Now, we put something into the machine, and we're going to consider that our input. Something is going to happen in the machine based on the instructions, and then we're going to get an output. Okay? In functions, relations, and graphs, the input is usually an X term. And when we do the instructions to the X term, our output is Y. All right, so everybody with me so far? So we have a machine, and the truth is we call this machine the relations because it is what governs the relationship between X and Y. Okay, let's make some sense of this. So let's use an example. Let's say our machine tells us to multiply x by 2, which is what we're going to call 2x. So I'm going to start off here and say, let the first x be equal to 3. So what do you think that's going to give us? If we put it through the machine, what did it say to do to x? It says to multiply x by 2. So what do you think y is going to be? Anybody want to guess? If the input is 3, remember we have an input and then we have an output. If we put 3 inside the machine, what will we get outside? What would be the answer that we get when the process happens to the x? Okay, somebody says 6. How do we get 6? Because when we put x in, we multiply by 2 because that's what the machine tells us to do. So y would be what? 2 times whatever we put in, 3. So our answer is 6. Let's take another look or another example. Let's say x is equal to 5. If we put 5 inside the machine, if we put, oh, I don't know why my pen is doing this. Let me see. It keep turning to the eraser. If we put 5 in the machine, and what does it say to do with our variables? It says multiply by 2. What would be our output, guys? 10. 10. Everybody with me? How did we get 10? Because our input was 5, and the relations that happening to 5 is that we multiplying it by 2. And so our output, just remember, output is on this side, and on this side is our input. Okay, hi. So right now we're just looking at the concept of what relations do. All right, so we have here 10. Everybody with me so far? All you need to understand is that relations is a relationship or some instructions that tell you how to change x values into y values. So again, let's take a look at another example. Suppose I tell you x is equal to 4. What would y be? What would be our value for y? Excellent. 8. Remember, it would be 8 because 2 times 4 is 8. Okay. Now, there's certain things we need to learn. So that's no problem. Let's take a look at the notes and then we're going to take it from there. So it says here, in mathematics, all easier, blah, 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 blah. This is the most important part here. Where we study relations between two sets, and the two sets of numbers. Anybody know what the two sets of numbers is? The two sets of numbers is always x and y. In this topic, we don't deal with no other variables but x and y. So this shows us how they are related to each other by using a set rule. Another word to describe relations is mapping. So these are some of the things we're going to be looking at today. Different rules, different representations, all of these awesome stuffs. So one of the things you just got to remember, there's a rule that is going to govern the relationship between x and y. All right, so let's look at some other representations. So let's look here. Here we have something called a mapping. Anytime you see any images like this, it is called a mapping. So I'm just going to write this here for us to keep in mind, a mapping. And here, the mapping shows us the relationship between our x and our y. And there are specific names for it. And I want to ask you, which one do you think is the input? Is the input the x or the input the y? Myrtle says x. What about everybody else? Y'all remember which one is the input? X is the input. And who is the output? Y. These are the things you need to remember. That's it. So there are different ways of representing these outputs. So I'm going to show you something now. Before, we were looking at the relations, right? Which means multiply by 2, which is how we have here 2x. Suppose I drew this. Let me see. So we have an x variable. I'm going to have 1, 2, 3, 4. And I'm going to circle it. So this is what we call a mapping. So again, what do we call the x values? We call it the input. There are different names there, but this is the ones we're going to look at for now. Then we have our y's. Suppose I do this. 2, 4, 6, 8. And what is our y's? Our y's is our output. And I tell you that these numbers in the x or in the input is related to the output using a relation. And in this example, how do I represent my relations? By using what? What is this thing in red? What do we call these things in red that I'm drawing in red? Yeah, but what are, well, arrows. Yes, they are the instructions, but it's arrows. That is how you show the connection between the x and y. Now let's pay attention to the numbers. We move from 1 to 2. We move from 2 to 4. We move from 3 to 6. We move from 4 to 8. What is the rule do you realize that connects us from the x to the y? Isn't this the same thing we did above? Exactly. So our relations here is multiply by 2. Everybody see now? This is what we call, this is what a relation is. A relation is a connection or a set of instructions or a set of rules that governs how do we move from an x value to a y value. Keeping in mind, x means input, y means output. Another word for input is domain. So sometimes CXC uses the word domain, and for y, they use the word range. Range or co-domain. And I'm going to show you the difference between specifically what range is and what codomain is. But most times they use the two words interchangeably. So let's make sure we understand this mapping here. The information from this mapping. We know we have what? Our x terms and we have our y terms. The y is the input. That's what we put in. And not the y, sorry. The x is the input and the y is the output. But how do we move from the x to the y? That's what we call our relation. And in this case, our relation is multiply by 2. So that's why we move from 1 to 2, 2 to 4, 3 to 6, 4 to 8. So before we continue, does everybody understand the elements of a mapping? So you understand input, output, you understand X, Y, you understand the relationship between two of them. That's very important. Now, in this specific topic, I want y'all to understand this topic is almost like a fun topic because there are different ways to represent the same information. So here we would have learned the mapping representation of a relation. Now we're going to learn something called ordered pairs. All of this, guys, is in the notes that I send you, but we're going through all of it now. That means that I could represent all of this information using X first, Y second. And it has to be in brackets and there must be a comma in between. So I would like to ask you, how would I represent the first relation ordered pair? Which one is the X? 1. So the first one is going to be 1, 2. What would be the second one? Somebody guess or somebody try. So we just did the first one, keeping in mind who always comes first. One, the X come first, but guess what missing? Where are my brackets? You cannot send.
I'm trying to concentrate here. I can't watch that right now.
Sorry about that. Guys, keep your mics muted. So as I was saying, you guys have the right numbers, but what happened to the brackets? A lot of students lose marks like this. So always take note. The answer, your ordered pairs must always be in brackets. Always. So it would be 2, 4. What would be the next ordered pair? Anybody, somebody, what would be the next ordered pair? So far, we did 1. Let me hear you.
3 and 6.
Excellent. 3 and 6. Next one. Last one. Somebody else. Let's go. What is the last ordered pair? Excellent. 4, 8. So essentially, we just learned 2 different things. We learn how to represent a relation using mapping. You know, this is the diagram version of it. So you have your X and your Y's, and then you have your ordered pairs. Everybody understand the representations, the ordered pairs? How do we get the ordered pairs? Who always comes first? The X value always comes first, and the Y value always comes second. So everybody with me so far, because we're going to do a quick small activity just to make sure you guys understand which one is the X, which one is the Y. Because as we go along, this concept is going to become more complex. Not more difficult, but more complex. So far, I see Jeffrey, Natalia, I think I saw Janella. What about everybody else? Let's go. Alicia, okay, good. Remember, I'm not asking you guys to do anything but confirm with me. Because we gotta move. Okay, so let's do a quick activity to see if you understand the concept of ordered pairs and the relation. So I am going to give you the ordered pairs, and I'm going to ask you for certain things. And I want to see if you understand the basics. So let's take a look. Let me just scroll this up so you can't use this. So let's go. I'm going to give you, let me go back. 1, 1. 2, 4. 3, 9. 4, 16. 5, 25. So these are my ordered pairs. I would like you 1A. So question 1. List the domain, members of the domain. List the members of the domain. Anybody remember which letter is the domain? Is it the X or is it the Y? Excellent. So that means that I need you to tell me all of the X values. And you should remember from each ordered pairs, which one would come first. So I have one answer so far. Let's go. Okay. Excellent. And you realize they said the members. So that means for every single ordered pair, what is the X value? And you should know domain means our input. And what is another word for our input? Our X. So let's go. That would be then 1, 2, 3, 4, 5. So excellent job. Everybody got that correct. Everybody, I love what I'm seeing. Excellent. B, list the members of the range. List the members of the range. So who are the members of the range? Excellent. Very good. So that's 1. let me use a different color. Let me use green. So that means that is our y values. And so that would be 1, 4, 9, 16, 25. So you write it down 1, 4, 9, 16, 25. I would like you to now answer this last question. Let me see if you pay attention. State the relation. How do I move from the domain to the range? What are we doing to these numbers to move from the X to the Y? What am I doing? What's the rule? What's the instruction to move from the X to the Y? Anybody know? It's excellent, excellent, excellent. We are squaring. Everybody seeing that? Because look at this. 1 square is 1. 2 square is 4. 3 square is 9. 4 square is 16. And 5 square is 25. So the rule is X square. Because remember, it would have been square root if the numbers were switched. But because we're moving from the X to the Y, you realize we have to square the X to get the Y. You see that, Cloris? So let's go. Everybody with me so far? So now we understand the terminologies. We understand what a relation is. We understand the connection between the X and the Y, because remember, the X is the input, the Y is the output, and the relation is what takes us from the X to the Y. All right. So before we continue, let's just go back to our notes, because remember, I want to go through it to make sure you understand the connection. So here you realize it says, oh, and I want y'all to note this because it's important for you to know all the way they describe the notes. Outside of the word mapping, they also use arrow diagrams. So some people use mappings. In the exam, they use both sometimes. So you just have to know that they mean the same thing. So the arrow diagram is the same thing as mappings. Okay? So let me just read this quickly. An arrow diagram is often used to represent a relation. The members of each set are listed inside a closed shape, and an arrow is drawn to connect the related members. Okay? For a relation to exist between the sets, there must be a rule connecting the pair of numbers or elements. And this rule must hold for all. So that means everything in here following the same rule to be connected to everything over here. Everybody with me? And so we know how to represent a relation as a mapping or arrow diagram. And we also know how to represent this information using ordered pairs. Okay, so let's take a look at the bottom here at the different types of other words that they use to describe. So far, what do we know? We know these 3 or 4. We know input, output. And just to be clear, we know input is the X, output is the Y. What other 2 words did we learn? We learned domain, and we learn range. And we also know that there's something called a codomain, which is still the same thing. Also, there are 2 other ones now. Image. Image also means Y. And sometimes they also use object as the X. Please take note of these things. The more you know, the less stressed you would be in an exam. If they use any of these terms, you should be able to remember, oh, your input mean X, domain means X, object mean X. Similarly, output means Y, range means Y, codomain means Y, and image means Y. We good to go? Everybody good to go so far so we could move on? Let me know. Type in the chat, good to go. Because all of this is, again, our foundational stuff. This is the concept that we're going to need to move forward. And to be honest, functions is just like algebra, just that it just has specific rules. So I'm going to let you guys know now, you're going to need algebra to do functions. So let's look at it now. So we have here defining a relation. So we already know a relation based on our discussion so far. It is two sets are involved, and we should know the two sets. We just call all the different names for the two sets. Look at here. These are the two sets, the X's and the Y's, are the inputs and the outputs, the domain or the codomain, the range, the image, the object. Okay, that's what they're talking about, the two sets. So we just went through it. We look at the fact that this is another way to represent the information. So look at it. Here we realize X would be what? This would be our domain. These are our values for our domain. And these would be our value for our range. So this is just another way where you put all of the domain members and then you put all of the range members. Similarly to what we just did, you realize the same example was used. So you realize we move from X to 2X. This is our next thing. This is another way to represent a relation. We move in from the input to the output. Everybody with me? So this is just another way to represent a relation. You could use words, you could use diagrams, you could use short expressions like this. Now, remember we spoke about the difference between the range and the codomain. Anybody realize what's different with this specific example? You realize it's the same thing that we've been doing. Look, 1, 2, 3, 4. 1 gone to 2, 2 gone to 4, 3 gone to 6, and 4 gone to 8. But there's something a little different in this example. Do you realize that we have numbers in Y that don't have a direct connection to a specific number? Everybody seen that? So here, what do you realize now? I want you to see this. Everything in Y is called the codomain. But you know which one is the range? The range is the number that is actually connected to one of the X variables. So all these numbers are in the codomain, but who is the only people in the range? Only 2 in the range. Only 4, 6, and 8 in the range. 7 is in the codomain because the codomain is everything. But which one is the range now? Only the numbers that are connected in the relation. They must be connected in the relationship. Everybody seen that? So look, it says here. So the subset of Y, and for those who don't know what subset is, it's like a smaller group within the bigger group. So our smaller group within the bigger group is our members 2, 4, 6, and 8. But the bigger group has who? The bigger group has 3 as well, 5 as well, 7 as well. Everybody see the difference between the range and the codomain? This does catch people all the time for paper 1. Everybody with me? All you need to remember is the difference. The range is the actual numbers connected in the relationship. But the codomain is just all of the members in the Y set. Hello, are you with me, guys? Are you with me? Okay, so let's keep it moving. Let's keep it moving. So all these things we know, we understand. So let's look at a worked example here. So they gave us an example of mapping. And here you realize that the range is equal to the codomain. This is an example where it's the same thing because guess what? There are no other members outside of the ones connected in the relation. So in this case, you see, it's the same thing. But in the previous example, let me just erase all of this stuff. In the previous example, you realize it is not. Here, the range and the codomain is not the same. But here, it is the same because they're equal. All right. So let's look at this worked example. Because remember, you have these notes. We're just going through it to make sure you understand what's on the paper. So it says, a relation is represented by the ordered pair shown. And you should know, what does the ordered pair give us? It gives us the X and the Y. So without looking at the answers, all right, don't cheat, eh? Let's try. Let's try to answer the questions without looking at the actual answers. Because we could do this. Yes, we can. So there we go. Let me move this out the way and let's take it step by step. So we were giving a specific mapping and a relation. We know this is our input. We know that this is our output. And I'm going to continue to write it because this is something that is thing. Y'all ready? We good to go? I'm so sad and disappointed. Nobody see what's going on. I intentionally make the mistake here. What's going on here? What happening? We good to go? Are we?
You have
What's
the
wrong?
output for X and input for Y.
Okay. I am intentionally doing these things to see if you are paying attention, because I'm going to tell you now, these are things people don't even realize. You have to pay attention to everything. X is our input. Y is our output. So Cloris side, excellent job. Let's go now. A relation is represented by the ordered pair shown below. 1, 5, 2, 7, 3, 9, 4, question mark, 23. State the rule for the relation. Anybody could pick up how they move from 1. So this is what they're moving from. 1 to 5, 2 to 7, 3 to 9, 4 to something to 23. Anybody could see how they got the 23? Okay, so Cloris is saying 1 times 4 plus 3. What is the general rule here? Let's see, because I'm going to tell y'all now. This is a huge part. So somebody said odd numbers. Okay. Odd numbers how? Remember, it's something we're doing to X to get 5. Are we multiplying by a number? Are we adding a number? And it has to be the same rule for all. Are we doing a combination where we first multiply, then add? Let's see. What can I do to 1 to get 5? Anybody have any ideas? What can I do to 2 to get 6? What can I do to 3 to get 9?
Are you sure? 2 times X plus 3.
Okay. So Chloe is saying 2 times X plus 3. Let's see if that works for everybody. So what she thinks the rule is 2x plus 3. Let's see. When X is 1, sorry about that. Yes, Myrtle, thank you. Sorry. I got you. So let's see. When we put 1 here, 2 times 1 plus 3. So let's see if it works for the first one. Yeah, because 2 plus 3 is 5. Does it work for the second one? 2 times 2 plus 3. 2 times 2 is 4 plus 3 is 7. Okay, it worked for the second one. Let's see if it works for the third one. 2 times 3 plus 3. 2 times 3 is what? 6. 6 plus 3 is 9. It worked. Everybody see what she did there? Guys, everybody see what she did there? So she figured out the rule. Let's see now. So what would the next one be? How do we get 4 though? It would be what? 4x plus 2. No, it's not that, guys. It would be 4 times what? It would be 2 times 4 plus 3. 2 times 4 plus 3. How much is that, guys? Mod mass. What's the answer for that? 2 times 4 is 8. 8 plus 3 is 11. Excellent. Now, here's what's going on now. They gave us the answer. How do we go back? So that means, let's use the formula she gave us. 2x plus 3 And we know the answer. What's the answer? The answer is 23. How do I solve for x? Anybody remember how we solve? We just learned this. Who should I move first? I should move. If you're solving for x, it means you want to know what this x value is. That means we need to get rid of the 2 and we need to get rid of the 3. Who would you get rid of first? You would get rid of the plus 3 first. By doing what? Moving it over. You realize why I told y'all algebra and everything? Because this is algebra. So there we go. When we move the 3, we're going to end up with 2x is equal to 23 minus 3. So what we're going to end up with? 2x is equal to 20. So everybody from here, what is x? How do I find x? I got to do what now? Divide by 2. Whatever I do on one side, I do on the other side. So x is equal to how much? 10. So I'll put the 10 here. Let's see if we are correct. Yup. Watch the rule. 2x plus 3. And it's all comes down to you determining how to find the missing number. Before we continue, let me give you one. Tell me if you could pick up the relationship here. I'm going to give you guys an easy one. How do I move from 1 to 4, 2 to 5, 3 to 6, 4 to 7? Who could pick up the rule here? What's the rule? What's the relation? Okay, Cloris says plus 3. Everybody agree or disagree? Anybody else have any answers? Let's go, let's go, let's go. You got to think for yourself. Is it true? If I add 3 to 1, what do I get? 4. Okay, that's correct. If I add 3 to 2, I get 5. So that's correct. So let me just mark it off. That's correct for here. The rule is correct for here. If I add 3 to 3, do I get 6? Yes. If I add 3 to 4, do I get 7? Yes. But we can't just write plus 3. What is the relationship? The relationship is x. Whatever x is, we add 3. So the relationship is x plus 3. Everybody see that? Your relationship must have x in it because remember you're doing something to x. So it just can't be plus 3. It has to be the x plus 3. Let's try another one. Let's see if you get this one. And instead of an increasing one, let's try a decreasing one. So let's see. 1, 5, 2, 10, 3, 15, 4, 20. What is the relation here, guys? How do we move from 1 to 5, 2 to 10, 3 to 15, 4 to 20?
X times 5.
Okay, times 5. Does everybody see that? Everybody see that? Confirm with me if you see it. Let's back check because remember you have to make sure that it works for all of it. It has to work for everyone. The rule must be true. If anytime, let's say you come up with a rule, right? You have to make sure all of it is correct. Let's say there's one that it doesn't work for. That means it's not the rule. So let's see. If I multiply 1 by 5 here, I get 5. Okay, so this is correct. If I multiply 2 by 5, do I get 10? Yep. If I multiply 3 by 5, I get 15. Yep. If I multiply 4 by 5, do I get 20? Yep. So here, how do I write it down though? I can't just write times 5. Using x, what would you write? What is the relation? What is the relation? Who could tell me? Because we know the rule. The rule, okay. Everybody see that? Everybody see why it's 5x? Because we know, even if you say 5 times x, but we know 5 times x is simply 5x. Okay? So we are good with that. So let's look at the next question. This asks, let's look at question number 2. So we finished with question 1. What is the image of 4? We found it. The image was 11. What is the input for 23? We found it. It was 10. So let's go. Let's get some ranking. Out of 10, how much do you guys follow so long? How are you feeling about what we've done so far? Keeping in mind that you already have these notes. Okay, 7. I see 8. 8. Talk to me. If anybody not understanding, this is your chance to tell me. Somebody learned it before, so it's easy for them. Okay, most of you, especially those who are currently in school, would have covered functions or should have covered functions already. So all of this is revision for you. So those who are learning it for the very first time, okay. All right. Jeffrey, where you gone? Okay, so somebody telling me they're learning for the very first time and kind of lost. That's okay. So I have a question. Did you get a chance to read it before class? I sent it since last week, Thursday. Did you read it before class? Did you go through it at all? Okay, so let's keep it moving for now, and then I'm just gonna do some quick recapping to look over some concepts that may be a little confusing. Okay. So we're gonna do types of relations now. So let's just go back from the top just to quickly recap. So we know whenever we have some numbers, the numbers, let me just scroll out some of the major concepts we need to cover. So we looked at the concept of a relation, where the relation can be considered as a specific instruction or rules that tells us how do we move from an input to an output. Okay, it's like a machine. You put something in the machine just do its thing, and then something just come out. What you need to remember is that what you put in is what we call the input. What you get out is what we call the output. But we have to be more specific. What do we put in? We put in an X value. What do we get out? We get out a Y value. What we've been looking at is the relationship times in by 2. So let's look at this specific mapping here, and we have different X values. So what are our X values? We got 1, 2, 3, 4. When I put 1 inside the machine, it's gonna multiply it by 2. So 1 times 2 gives me 2. When I put 2 in the machine, I multiply it by 2, and we know 2 times 2 is 4. When I put 3 in the machine, 3 times 2 is 6. Similarly, 48. So we understand that in order to move from X to Y, we have to apply the relationship rule or the relation rule. And in this case, it was times 2. When we finished looking at the mapping representation, we looked at the ordered pairs. It's the same way of representing all this information with less drama. When we say less drama, what do we mean? We simply just put the X value first, the Y value second for each relation. So we have the first one, that's the first one. This is the second pair, that's the third pair, and that's the fourth pair. And that's how we represented it here. First pair, second pair, third pair, fourth pair. Okay? And actually, don't worry, we're gonna go through it again. I could go through it one-on-one with anybody who needs me to. So you could probably just follow along for now, and then we're gonna work from there, okay? So don't stress yourself too much. So all we focused on is the concept of the input and the output, the X's and the Y's, the domain and the range and the codomain. And now we actually understand the difference between the range and the codomain, okay? Another word to keep in mind is image. An image simply just means y again. Similarly, object simply means your x value. All right. So we looked at some examples using those concepts. Now we're going to move along. There are different types of relations. In CSC, you only need to know 3. And the truth is, they're really governed by the way the arrows are set up. So let's take a look here. We see we got specific relations here, right? So we know we have our A, which should also be known as what? Our input, or X. And we have B, which we already know is our Y, which is also what? Our output. So don't be afraid. When you see things like that, just label it input, output. Everybody with me so far? In our previous examples, you would realize we had one number going to one number. What you realize different here? Do you realize that 2 is going to different numbers? So 2 going to 6, 2 is going to 8, 2 is going to 10. So it means we have different types of relations. All of them do not look the same. And these are the types we're going to look at. We're going to look at one to many, where one element in the domain is mapped onto more than one element in the codomain. And let's be real, that's pretty self-explanatory. One to many. So one element in the X going to many elements in the Y. Everybody have that? Just tell me yes, no, got it, just before, like, so y'all understand how we're flowing. So we're just looking at the different types of mappings or the different types of relations. Okay, so we have a one to many. And guess what we have now? We have a many to one. What does that mean? That, for example, look here. How much things going to 8? There are 2 things going to 8. 2 is going to 8 and 4 is going to 8. This is a perfect example of many in your X or your input going to 1 in your output. Everybody see how these things come to play? The one to many, the many to one. Next, you realize we have a one to one. I'm looking for it here, but I'm not seeing it here. Oh, look at here, up here. One to one. And that's what we've been doing so far. That's what we've been seeing. So this is a one to one. One element in the domain is going to one element in the range. One to one, one to one. That's what we've been looking at so far. All the examples we've been doing has been using a one to one. Only one going to one going to one. So these are the 3. One to many, many to one, a one to one. All right. So what we're going to do is look at an activity to see if we understand the different types. So let's go. For the first one, this is easy. What type of mapping is this one? Here. What type of mapping is this one? Let me zoom in a little bit. Take a guess or determine it. What type of mapping? We got 3 of them. Is it a many to one? Is it a one to one? Is it a one to many? Okay, only 2 persons responded so far. What about everybody else? It's pretty clear. Just look at the drawing. Is elements going one to many or is going directly one to one? Let's go, because if you cannot do this, this is a specific skill that you need. Because when we move forward to the actual functions, you have to determine what type of relations that CXC give you, and they're going to tell you what to do. So this is something you must understand. Excellent, everybody. This is a 1 to 1. You could use this dash or you could use the word to. Either is pretty okay. Excellent job. Guys, I think current is leaving. Everything in my house is getting dark. Or I don't know if it's just a dip in electricity, but if I get logged off, you know, current gone. Such a horrible struggle to have. I don't know what's happening outside. Y'all could see me still? Yep, my fan is off now. My lights is going dark. So if I get locked off, I guess we would end here. I don't even know. Okay. They're coming back up. I just hope nothing mash up. Okay. All right. Y'all could hear me still? Y'all could hear me still? Okay. So let's keep it going. Let's keep it going. So let's look at the example 2. Let's evaluate it. What we know for a fact. So you got 3 to choose from, right? You have the one-to-one, you have the many-to-one, and then you have the one-to-many. So it's 1 out of the 3. For number 2, we definitely know it can't be no one-to-one because you see how there's lots of drama going on. But which one is it? Is it a one-to-many or many-to-one? Let's see, guys. What do you think? Look at it. Look at it. Is it a one-to-many or many-to-one? 3 people respond so far. What about everybody else? Take a try. It can't hurt to try. Just take a try. Okay, I've seen some more responses. The answer, drum roll, Natalia, you're sure it's a one-to-one? Look at it. That could never be no one-to-one. Look at it. Look at the difference between how a one-to-one look in this one. So you know that's the last answer you should pick. This, my good people, is a one-to-many. How do we know that? Look at it. 4, which is 1, is going to 2 different things. 4 is going to 2 and 4 is going to -2. Look at this one too. 9. 9 is going to 3 and -3. So this is what? A one-to-many. Ash, you see the difference? You see it now? Let me know. So excellent job, everybody. Let's go. Number 3. What type of mapping is this? What type of relation is this? Is this a one-to-one? Is this a one-to-many? Is this a many-to-one? Excellent job, guys. Excellent job. Last one. Last one. Last one. Excellent job. So this one was a one-to-many. I want to point out something after. No, somebody said many-to-many. Look at the general trend. So this one is, let's see, a many-to-one. Now we're gonna tell you, you see, it got this thing called many-to-many. You know what? I'm not gonna focus on this one because it's not on the CXC syllabus. They only acknowledge 3. So it's not that the many-to-many wrong, to be honest. It's not that the many is wrong. It's just that it has to be 1 out of the 3. You see what I'm saying, Myrtle? So the last one is a many-to-one. All right, so how everybody feel about identifying the different types of relations? Because this is important. So far, we understand the different types and how to identify. Now, you want to joke? Y'all could do it when we using the mappings. Can you do it with the ordered pairs? Let me see. Let me see if you could do it with the ordered pairs. Let me give you an example. I was hoping I saw an example, but I have to create my own. So let me do that now. Let's try number 1. You're going to tell me, my good people, if it's a one-to-one, many-to-one, or one-to-many. So let me go. 1, 4, 2, 5, 4, 8, 6, or 9, 12. So let's go, guys. What type of mapping is this? This requires you not to pay attention. Is this a one-to-one, a many-to-one, or one-to-many? This is where your thinking caps got to come in. So I have one person. Okay. I'm accepting any answers, wrong or right. It doesn't matter. I just want you guys to try. So let's go. One person made an effort. Excellent job for trying. What about everybody else? Okay. One to many. What about everybody else? If you're not sure, just say you have no idea how to look at it and determine. That's perfectly fine. But guess what the answer is? The answer is 1-to-1. How do we know if it's 1-to-1? Because each number in the domain, what are the numbers in the domain? Let's look at it. 1, 2, 4, 9. All these numbers map themselves to completely different numbers. So what do they map themselves to? 4, 5, 8, 12. Let's draw this so you could see. Let's draw it to see. 1, 2, 4, 9. Mapped itself onto what? 4, 5, 8, 12. You realize none of these numbers mapped onto the same number. None of these numbers came from the same number. Everybody see that? Everybody seeing that? Let me know if you understand it, because you have to. This is important for you to be able to tell. You should not only be able to do so using the mappings, you have to be able to do so with the ordered pairs as well. Let's try another one. Let's try another one. 2, 4, 2, 6, 3, 8. Ooh, what was that? 3, 8. 3, 12. What is this? So this one was a 1-to-1. What is this now, guys? What is this? What is this? So I hear Chloe saying 1-to-many. What do you guys think it is? What do you guys think it is? Look at it. What type of mapping is this? What type of relation is this? Is it a 1-to-1? Is it a 1-to-1? Is it a 1-to-many, or is it a many-to-one? Let's look at it. We have 2. We got 2 again. We got 3. We got 3 again. So you already know the first part should be what? Because you realize 2 going to 2 separate numbers. So what would that be called? If we look at only these 2 here, what would you consider this? This ain't a 1-to-many. Yeah, see why it's not a many-to-one? Let's draw it. Let's draw it. Let's go. So I'm going to have 2. I don't need to write 2 again. 3. I don't need to write 3 again. These numbers are being mapped on to 4, 6, 8, 12. Let's show the arrows. 2 gone to 4, but 2 also gone to 6. 3 gone to 8. 3 also gone to 12. Everybody seeing that? So what is it then? This is a 1-to-many. A 1-to-many. Everybody seeing that? Let's try one more. Let me see if you can catch it. Let's try another one. 1, 5, 2, 5, 3, 5, 4, 6. What is this? Pay attention. Look at what is happening. Who going to who? That's what you should be looking at. For the first one, who is going to who? Second one, who is going to who? Is there a common number? Oh. Oh. Come on, guys. Think about it. It can't hurt to try. It cannot hurt to try. So this one is, let's do it out to see, it's a many to one. Who is the one number a lot of them going to? Who a lot of people going to? Well, you realize here 5, 1 gone to 5, 2 gone to 5, 3 gone to 5. Everybody seen that? So if I was to draw out this mapping, let's go. The mapping here would be 1, 2, 3, 4, but it would only be 5 and 6 over here because check what's going on now. 1 gone to 5, 2 gone to 5, 3 gone to 5, and 4 gone to 6. Yeah, you get it correct. So this one is a many to one. Everybody see that? And guess what? That's it for relations. We are done with relations. There's nothing else to learn on relations. That's it. We're done with relations. Once you understand these concepts, X, Y, input, output, domain, range, figuring out what the relation is, figuring out the types of relation, figuring out how do I move from the X to the Y. Everybody see that? So I have a question for you now, unrelated to this specific part. But before I do that, how do you feel about the types of relation? Do you understand the types of relations? The one-to-one, the many-to-one, the one-to-many, and in both forms, do you understand it as the mappings and do you understand it as the ordered pairs? Let's go, let's go, let's go. Okay, get in there. All right, this again, this information is extremely useful in paper 1. They just ask questions like this all the time. They're gonna give you a mapping or give you some ordered pairs and ask you, what type of relation is this? Another question that comes is this a function or not? Okay, you're having a little trouble with the ordered. No problem at all. So I think I'm going to take this opportunity. There's a test that I gave my 4th farmers last year. I want us to look at the first one. We should now be able to look at the questions and answer it. So that's what I'm going to do before I move forward, because I think it's important to be able to answer the questions. It's multiple choice. I'm going to change the question for number 1. Don't read this. All I want you to do is tell me what type of relations is each. So for this one, because the truth is, we're going to do this next. Before we leave, we have to do this next. But before we get there, let's answer these questions. What type of relations is each? So let's look at the first one. The first one we have 1 and -5. 3 to 1, -5 to 4, 4 to -2. What type of relation is this? Is it a many to one, a one to many, or 1 to 1? What are you looking for? You're looking to see if numbers are doubled. You have to look for, is there the same number in the domain? Let's look. 1, 3, -5, 4. All these numbers are different. Now let's see if there's any numbers in the range that's alike. What do we have here? We got -5, a 1, a 4, and -2. What does that say? All these numbers are different. What type of mapping would give us different for both the range and the domain? You see what I'm doing? Everybody picking up what you should be looking for. This is a 1-to-1 because no X values are repeated. So it could never be a 1-to-many. No Y values are repeated. So it could never be a many-to-one. All of them are different. So this is a 1-to-1. Okay, I've seen some people saying if they understand it better now. Let's look at number 2. Let's check this now. Look at the domains or look at the X's. Let's look at the X. We got 2, we got 3, we got 4, and we got 5. All of them different. But now let's look at the Y's. We got 7, 7, 7, 8. So what is this now? All the X's are different, but what's going on with the Y's? A lot of them going to the same number. So what is this? Is this a 1-to-1? Is this a 1-to-many? Or is this a many-to-one? Remember, you're talking about the first dash, when you got a dash, this number talking about the X, this number talking about the Y. What is it? We know that all the X's is different, so it has to be 1. But do we have any repeated Y's? Look at it. We got 7, 7, 7. Sorry, I put the 1 in the wrong place. 1's supposed to be here. Why is it 1? Because all of these numbers are going to 7. Everybody see that? And how much numbers are going to 7? 2 going to 7, 3 going to 7, and 4 going to 7. So fix our answers now. Is it a 1-to-many or many-to-one? It's a many-to-one. Because 2 gone to 7, 3 gone to 7, 4 gone to 7. That is many-to-one. You see the difference between the many and to one and to 1-to-many? You have to know the difference. Let's look at C. What is C? Check what's going on now. We got a 1, we got -1, we got a 1 again, and we got 6. Then we got -5, 6, 5, and -3. What is this? What is this? Which number is being repeated? Look at it. We got something happening here. If you need to draw out the map, doing 1 is being repeated, are correct. Look, we got 1 here. And we got 1 again. So that 1 number, what is it going to? Is it going to different numbers? Everybody seeing that? Yeah. So what is this then? Is this a 1-to-many or many-to-one? Because this one is going to different numbers. So what is it? This is a 1-to-many because that 1 gone to a -5 and a +5. Y'all want me to draw out the mappings for them? If you want me to draw out the mappings for them, I could do so to help make it clearer. Yeah, you want me to do that? Let's do that. So let's look at A. Let's draw A. And I hope you guys are taking the opportunity because maybe that's going to help you. Listen, if you have to draw out the mappings to see it, you do that until you get accustomed. Don't ever be afraid to do what you need to do to get the answer. So let's draw A. How do we have A? So we got 1, 3, -5, and 4. It is going to what? It is going to -5, 1, 4, -2. And what you realize here is that all of it going to specific numbers. So you can see it clearly. What do you realize here? It's 1-to-1. Yeah, draw it. If you got to draw it, draw it. So everybody see how this one was a 1-to-1? Let's do B now. Let's do B. So what is the numbers for B? We got 2, 3, 4, 5. Who 2 gone to? So we got 7 and 8. Just 7 and 8. So let's do it now. So 2 gone to 7. 3 gone to 7, 4 gone to 7, and 5 gone to 8. Everybody see how this is a many to one now? Many to one. Everybody seeing it now? You seeing it better? Let's try the last one. See. 1 minus 1. You don't ever write the number twice. So you see how we got 1 twice, we just keep it as 1. And then 6. You only write different numbers here. And what do we have in our thing? We got -5, we got -3, we got 5, we got 6. So let's do the relation now. 1 gone to -5. -1 gone to 6. This gone down here. 1 gone to 5 again. And 6 gone to 3. Everybody see that? I just realized that I put in this trick question for a reason. Anybody realize what's going on here? I just remember I put in this question as a trick. Everybody realize what's going on with C? I just realized. C was an intentional quick question. Oh, it's -5 and +5. Okay, thank you. So it's -5. Wait, where is it? 1 to +5. Yes. So let's go back. It's not to -5. It's +5. 1 to +5. All right, that's it there. Thank you. All right, let's go. What do we realize here? You see why this is a 1 to many? Because 1 is going to both -5 and +5. So everybody work out the last one for me and tell me where you get. I need that one from everybody individually. Send it to me directly. Oh yes, and 6 to -3. Why you put to -5? Who just draw that? How y'all doing that? Somebody just draw my board. Who did that? Okay, gotcha. So this arrow is pointing to -3. Thank you very much. Excellent. So let's go, guys. Number D, what is that? I've seen some answers already. What about everybody else? What is D? Is it a many to one, a one to many, a 1 to 1? All right, I'm waiting for a few more persons to tell me. And then we're moving along. So D, all these numbers are different, both in the X and the Y. So this would be just a 1 to 1. That's what we call it, a 1 to 1. Because to be honest, it's the same thing, 1 to 1. All right, let's go. Number 2. Everybody tell me what you think the answers is. All of the X value or inputs are called what? Is it A, the domain, B, the range, C, the relation, D, the function? What is it? Is it A, B, C, or D? Let's go. All right, waiting for a few more persons to respond. So the answer is A, correct. Excellent job. Let's look at 3. All of the Y values or outputs are called what? A, B, C, or D? Excellent. Excellent job, everybody. Excellent. Now, let's look at number 4. Sorry. So let's look at number 4. And guys, these are all the easy stuff, because remember, we're just doing relations. This is not functions yet. So let's look at this diagram. And they ask us a question. What is the range of the relation shown on the mapping? So based on this diagram, is it A, B, C, or D? Let's go. Make a choice still, even if you're not 100% sure. They're asking you for the members of the range. What is it? You have to remember which one is the range and which one is the domain. Is it the left-hand side or the right-hand side? And then what are the elements? Which one connects? Only one person responded so far. What about everybody else? All right. The answer is A. Why? This would be what? Our domain. We just looked at what domain means. So what is the range? This is the range. So we're looking at all the elements in the range, which is 3, 5, and 8. The only option that has 3, 5, and 8 is A. You see that? That is why they ask you for the output. That's why these two questions come back to back, because the output is the same thing as the range, and you got that right. So we just got to remember that these are the values of the range. Last one. In the given relation, what domain value correspond with the range value -2? So who connects with the range value -2? Is it A, B, C, or D? 2 people respond so far. Let's go. You have to be able to answer these questions, guys. So what should you be doing? You should be looking at the Y values to see where you find -2. Where do we find -2 in the Y? And you see why they put this question, because it could confuse you. Because some people would pick D, which is wrong. Because the Y value with -2 is this one. And they ask you what domain value corresponds. So that would be our 0. Hence, the answer is B. Excellent job, guys. Excellent job. Last but not least, let's do this last one here. State whether the followings are functions relations or not. We can't yet, but what we can determine is if it's a one-to-one or many-to-one. So let's do that. This is the last thing we're going to do here. And then we're going to do the quick introduction on functions. And the next class, we're going to continue. But let me ask y'all a question. So far, how are you feeling about what we're doing? Everybody understanding? Is it pretty okay? How you feeling? How you feeling? Because I think we've done a lot. Everybody following, everybody understanding. Okay, so I'm getting some rates, I'm getting some feedback. Some people were getting a little stumped. Okay, remember the video recording is always there for you to go over and look at. Also this Sunday, I think I'm gonna be free. So maybe if you want to book a session with me, we could do so. All right, so let's keep it moving. Let's look at this section B. All we're gonna do is state the type of relation, because I'm gonna tell you the truth. What we're gonna learn next, okay, gotcha, Ash. What we're gonna learn next is when to determine whether a relation is a function or not. So that's what we're gonna do next, and that's where we're gonna end class today. And Wednesday, we're gonna continue with our functions. So let's go. I think number 5 is the easiest. What is number 5? What type of relation is number 5? Let's go. Quick. I just need at least 1 or 2 persons to tell me the answer, and we keep it moving. Excellent. That's a simple one. You could always find your one-to-one. So this is a one-to-one. Okay, let's do number 4. What is number 4? Ooh, you guys keep making this mistake. How can it be a one-to-many, guys, when 2 numbers go into 1 number? This is the part I'm gonna tell you. You're gonna have some arrows that go straight. You know the arrows we care about. You see these 2 arrows here? We don't care about these 2 arrows here. You see the arrows that are not going straight is what would determine what the entire relation is. Everybody see what I mean? So what you think that we need to pay attention to? We need to pay attention to these two arrows. These two arrows that gone off. And what do you realize is happening with these two arrows? It is a many to one. Exactly. So you see, I'm glad that we did this so that you realize it can always have one that going to one, but it cannot be a one-to-one if all is not one-to-one. So in every type of relation, you would always have one number going to one number separately. Everybody understand that? What you are looking for is the diversity that is happening. So you're looking for the arrows that are not going to a specific number. That is what is going to determine the type of relation. So the two red arrows, what do we realize about them? They are going to one. So that means this is what? This would be a many to one. Everybody with me? Everybody getting a little clearer between the difference between a one to many and a many to one? Because remember, two different elements are going to 18. That ain't to one. That's the first part you can't get wrong. Because you realize more than one element, so 5 and 7 are both going to the same number. That is why this is called a many to one. Natalia, you see it? Let's look at number 3. What do we have here now? Is this a one to many or many to one? Let's go. Everybody talk to me. Talk to me. Two people so far. What about everybody else? Excellent. Very good. This is a one to many. Because how? Remember, we don't care about these ones that are going straight. We don't matter. Then they don't matter. What matter is these here that are going off. We have one number, which is 2, going to 2 different numbers. What does that mean? One to many. That's how a one to many look. Everybody see that? One number going to 2 different numbers. The second one was 2 numbers going to 1 number. That's how you look at it. So let's look at number 2. What is number 2? Which 2 we don't count? We don't count. We're not going to count 4 to 4 because that's a 1. Even though the arrow is crossing, guys, it's still 1. They still 1 to 1. Oh, shucks. I give I the answer. Sorry. I just give I the answer. Even though these arrows crossing, what you realize? Each number going to a separate number. Everybody realizing that? So the diagram is just to confuse you. But this is a one to one. Everybody see it? Let me just erase it. Look at it again. -3 going to 0, direct. -1 going to 4. Actually, I made a mistake. That's not a one to one. That's a many to one. Yeah, you're right. Yeah. Everybody see that? Why is it a many to one? 2 things going to 4. Who going to 4? 4 going to 4 and -1 going to 4. You seen it? You see how the arrow is a little confusing? To be honest, it catch me too. So this one is a many to one. I'm proud of you too. A many to one. Last one, number 1. What is it? Let me see if you can catch this. No, you just get catch again. So I seen 2 things going to 1 number. You ain't seen the 2 things are going to 1 number. You see it? Everybody seen it? Look at it here. 18 is going to 11. And who else going to 11? 6 is going to 11. So what is it then? Look at it. We're only going to 1 number. So what is it? This is a a many to one. So that's it. That's where we're going to end class today. I just want to show you guys one thing and that's it. So hopefully you guys get, I think you guys should copy down some of these here. Look at the recording and copy down some of these examples. It's very important to have them in your notebooks because you're going to have to be very strong in identifying the types of relations. So I'm just going to show you guys one thing and that's where we're going to end class for today. So where did we reach? Where did we reach? Let me see. I just want to teach y'all one thing before you go. No. The function, a function is a relation, but a function is only two types of relations. A function, so I'm just going to tell you guys this and next class we're going to look at it. A function is either a one-to-one relation or a many-to-one relation. You know what the key point is? That it only going to one specific answer. So one-to-one or many-to-one. So everything we did before, we can determine if it's a function or not. So let's just quickly look at the examples that we had before. And now that we already labeled them, we could determine who is a function and who is not a function. So let's go. We know one-to-one is a function. So we can label this one a function. Let me just zoom in. Because again, you see why I was focusing more energy here, because once you know the different types of relations, finding out who's a function is the easiest part. So once it go into one, it's a function. So this is a function. So one-to-one is a function. This is not a function. Why? Because it gone to many. This is not a function because it gone to many. But the last one, this is a function because it gone to one. Okay? Similarly with the questions that we did, we're going to just label who is a function and who's not a function, and then we take it from there. And that's where we're going to end class. So we now know a function is just a relation that creates one output, one specific output. So let me go. It says here, which one is not a function? So which one is not the function for this question, guys? Now that we already label it, A, B, C, or D? Exactly. So C would be the answer for this question, because the first one is a function because it gone to one. The second one is a function because it gone to one. The last one is a function because it gone to one. Excellent. Let's look at the last few that we were looking at. Is number one a function? Yes or no? Yes, function. Is number two a function? Yes, because it's many to one. Is number three a function? No, it is not a function. Is number four a function? Yes, it is a function. Last one, is number five a function? Yes, it is a function. And guess what? That's it. So we know what a relation is. We know the different types of relations. We know how to represent relations in the two different ways, as the mapping or arrow diagram and as the ordered pairs. We know how to determine whether a relation is a function or not. So that's it for today's class. Everybody just give me a quick ranking of what you understood from today's class, everything in general, out of 10. And then I have one quick notice about the SBA. And I have to rough up some of y'all. I have to rough up some of y'all tonight because one group done get all their questionnaires sent out and all their data collected. And the other group, nobody ain't even responding in the group. And I'm gonna call y'all this weekend and rough up all you on the phone. Okay, so I'm seeing generally good. 7, 8, 9s. Okay, good. All right, so SBAs, we need to finish our SBAs by December. On Monday, by next week, Monday, I have to send in my list of candidates who will be registering privately. I will not be registering anybody who I don't hear from. I'm telling you the truth. If you don't talk in the class, you don't send no work, I'm gonna be honest with you and tell you straight up. So if you ain't contribute to the SBA either, you can't get the grade. So please, when I message in the SBA group chat, please respond. Please contribute, do your part. All right. So that's it for today's class, people. I'm gonna see you guys on Thursday, and we're gonna continue with now the harder, I won't even say harder, the more complex version of functions. So message me if you have any questions. Have a good evening.